Hello again. 2.4 RSG wrap-up video. Unusual that we're doing an RSG wrap-up video, but I changed the assignment from what the paper version was, what the Go formative version was, so we get to make a video. Let's share the screen. Very short, only 6 problems reviewing recursive and explicit equations. And before we even begin on this, I'm going to share the module OneNotes, which I keep sending out in the chat, especially for page 5. Right? There's explicit equations, recursive equations, right? Where they come from, how they work, right? So if it's linear, we've been writing it y equals mx plus b, or y equals b plus mx, right? Where m is still the common difference, how it's changing. The b is still the start value. Of course, the x and the y are just any point on that line. Okay, so I would definitely be using this, and especially important on the RSG that we're looking at today, how we change equations when the start value isn't 0. Right? We're actually going to see some that don't start at 1, but start at different numbers. Okay, so let's go back to that. All right, so number 1, we want the explicit equation. So we need the start value, we need the change. Okay, so hopefully first thing that we're doing as we look at this, we look at the y values, the output values. So it goes from -4 to -11. So that is subtracting 7. Subtracting 7 each time. And of course, we can't just look at the y values, the output values. We have to look at the x values also. And in this case, it's just going up 1. So we don't have to do any extra work to find the rate of change or the common difference. We know the common difference is -7. Okay. And then in this case, right, our start value is whatever the first value in the table is. So our start value is 2, -4. Right? We haven't started at 2 before. We have. Back in some older homework, we had some problems where we started at different x values. Okay, so now that we know our start value and our common difference, let's label this. So again, for our explicit equation, the output, right, this is the same as y equals, the output equals. A couple different ways to write it, okay? We could say that we're starting at -4, and we are subtracting 7, right? If we were starting at 0, this would just be x, we'd be done. We've talked a lot about when we start at 1, when the x is 1, our equation turns into x minus 1. So it would make sense if we start at 2, our x turns into x minus 2. Okay, so again, we're starting at -4, we're subtracting 7, x minus 2 times. And again, this x minus 2 is because our first x value is 2, right? This minus 2 here is because our start value is at 2. Okay. We might as well keep color coding on there, right? This minus 4, this is our start value. That's because of that minus 4. And that negative 7, oh, let's go with purple. We like purple. This negative 7. Oh, I should have gone pink to match this pink, but that's okay. So that's where those different numbers come from in that explicit equation. Now, if you wrote it y equals mx plus b, right, it's obviously going to be the same numbers. So the output is m is our common difference, so negative 7. Right? Our common difference is always attached to our x. But again, since we're starting at 2, that x would turn into x minus 2. And then our start value of minus 4. Let me move those dots, those circles out of the way so you can see those. Okay. So either one of those explicit equations would be correct. All right, for the recursive equation. Right, so again, our start value, which I don't know if I can bring those back. I can, that's awesome. All right, so for our recursive equation, we need our start value. So f of 2 equals negative 4. Right, our first input is 2, the output is negative 4. This part of the recursive equation never changes. And then our change is minus 7. So there's that. Okay, all right, let's go ahead and clear those again. So now for this table, the explicit in recursive equation. So again, first thing we need to do is find the start value, find the change. Okay, so our start value, negative 1 2/5. Because that's the first value given to us in the table. We also need to figure out how is it changing each time, right? Using the fraction might be confusing, but if we just look at 2, 10, 50, obviously it's not adding the same amount because it adds a fraction, then it adds 8, then it adds 40. But 2 times 5 is 10, 10 times 5 is 50, right? So our change is that it's multiplying by 5 every time. 5 is our common ratio. Okay, so we've got our start value, we've got our change. Let's write our equation. Oops. Now, for this, I'm going to go back to the notes real quick because this has a common ratio. So we know that this is going to be exponential, right? So our equation is going to look like one of these. Okay, we have to have an exponent in our equation if it's exponential. Oh, it erased my information. That's unfortunate. But f of x equals, so we start at 2/5. and it's multiplying by 5, right? And usually it would just be to the x power, right? If we were starting at 0, it'd be to the x power. When we start at 1, it changes to x minus 1. And in the last one, we saw that if it was 2, it'd be x minus 2. So x minus 2, x minus 1, x, hopefully we can figure out, so if it's negative, minus negative 1 is the same as plus 1. So 2/5. Again, let's show where these numbers are coming from. So here's our start value. There's our start value. You know, it erased my common ratio of 5 over here, so let's draw that back on there. Wow, that's terrible, but you get it. Let's try that again. There we go. Now you can actually tell what it says, right? It's multiplying by 5. So there's where that 5 comes from. And then again, since we're starting at negative 1 here, that's what makes this become a plus 1. Right, just like in number 1, we started at 2, it was x minus 2. Here we're starting at negative 1, so it's x plus 1. All right, and then for a recursive equation, start value f of negative 1 equals 2/5, right? That's the first value we're given in the table. We assume that that is our start value. F of x equals f of x minus 1. The current term, the current output is the previous output, and we said it's times 5. Again, for the multiplication, dot shift 8 gives that to you. For exponents, like we had up here, shift 6. And then we just have 2 explicit equations left for 5 and 6. So we need to find points on this line. So let's see, we've got our y-intercept right there. Easy to see that. We go along our line until we find another point on the line that we know the exact points. There's one right there. We keep going. There's another one right there. So hopefully we can see our pattern of how it's changing each time. So it's going down 1, right 3, down 1, right 3. To get to the next point, it's the same movement. It's the same every time. So our slope, our rate of change, our common difference is negative 1/3. Our y-intercept, our b, is where it starts on the y-axis, which is right there at 2. So our explicit equation, y equals negative 1/3 x plus 2. Again, the plus 2 is where it starts on the y-axis. It's the y-intercept. This negative 1/3 is because it's going down 1, right 3. And last one, number 6, we talked about this in class yesterday a couple times in our 2.2 RSG, I think it was. So again, we need to find points on this graph to start with. So we've got a point right there at 1. We go up We don't know where that is. We don't know where that is. We know where that is, though. And then there's not another point on there. We're like, oh no, what do we do? Well, we use our math skills. It's right here. And I'm gonna have to draw it. Right, so here the output is 1. The y value is 1. And it's 1, 2, 3, 4. So here the output is 4. So this curve makes it look like it's exponential. Which means it has a common ratio. So we need to figure out, what do we multiply 1 by to get 4? 1 times 4 is 4. So our common ratio is 4. So we're starting at 1 and it's multiplying by 4 each time. So for our explicit equation, f of x equals, and again, this is exponential. So a times b to the x power is what our first thought is. So we're starting at 1 and it's multiplying by 4 x times. And of course, we don't need this times 1. When you multiply by 1, it doesn't change your answer. So you could just write it as f of x equals 4 to the x power. We did it. All 6 problems, good practice, good review, very helpful before our test. Hopefully that was helpful. Goodbye from Mr. Bear. In.